Hi Year 11 Mathematics Advanced students. Today we're continuing on with the topic of functions and we're learning about cubic functions. So a cubic function has an equation where the highest power of x is 3, such as fx equals kx cubed, fx equals k bracket x minus b all cubed plus c, or fx equals k bracket x minus a bracket x minus b bracket x minus c. This is where a, b, c, and k are constants. We're going to have a look at some examples today. So our first example is to sketch the graph of the cubic function fx equals x cubed plus 2. So to sketch the graph of the cubic function, what we're going to do to start off with is we are going to draw a table of values. So let's just quickly draw that up. I think that should be enough. So we have our x values on the top and we're going to go from -3 to 3. So we have -3, -2, -1, 0, 1, 2, and 3 on the top. And then, I'll just tidy that up, we'll have our y values on the bottom, and that's what we need to calculate. So to find our y values, we substitute our x values into our equation. So we have f of -3 equals -3 cubed plus 2. So we substitute that into our x value into our equation to get our y value of -25, and we put it in our calculator to help us out. When we sub in -2 into our equation, we get -2 cubed plus 2, and that's -6. Then we should sub in -1 for our x. When we do that, we get 1. Should sub in 0, and when we do that we get 2. Should sub in our +1 in, and when we do that we get 3. Sub in 2 for x, and when we do that we get 10. And finally sub in 3 for x, and when we do that we get 29. Now we have our table of values, we can plot these points in order to graph our cubic. So what we're going to do is, over on our graph, it's a blank graph for us today. We are going to work out an appropriate set of axes. So what we're going to do is, going along our x value, we're just going to go from 1, 2, 3, and 4. And going along our y, and our negative values for our x, so -1 to -4. And then going up, we're going to go up by 5s, okay? So this will be 5, 10, 15, 20, 25. And go down by 5s also. So now let's plot our points. So the first point that we want to plot is -3 -25. So that will be the point here. Then we have -2 -6, so it will be here. We have -1 1, so that's just above the x-axis. Then we have 0 2. Yep. Then we have 1 3. Then we have 2 10, and then we have 3 29, which is going to be slightly off our page. So now we just want to connect our dots up in the shape of a cubic. And there we go. There we have it. So now we just want to write our equation of our cubic on our line. So we would write f of x equals our x cubed plus 2. Now, for part A of this, once we've sketched, we want to state its domain and range. So for a cubic, our domain and range is always going to be negative infinity to infinity for our domain, and as well negative infinity to infinity for our range. So just remember that the domain is the x values it can hold. So any x value is going to work in this function, and range is what y values it can hold. And again, any y values can work for this function. Then for part B, we want to solve the equation x cubed plus 2 equals 0 graphically. So what we've done is, this is our y value. Our 0 is our y value that it has been put in our function. So we want to find out what our x-intercept is. And it says solve graphically. That's one of the key parts of this question, is it says solve graphically. So that means that the answer that I get may be slightly different to the answer that you get, but it's graphically and it is based off your graph. So it's very important that you look on your graph, and where that occurs is what you write that down for. So if we go up to our graph and we have a look at where our x-intercept is, you will note that it is in the vicinity of that point there. Now, because it is just a sketch of our graph, we do have a quite accurate x and y axes, but what we need to do is we just want to see approximately where that point is. So approximately that point is -1 point something. So it's just a bit greater than -1. So I'm going to say that it's like -1.2 that it crosses through. So the root of the equation is approximately x equals -1.2. Now, because it says graphically, this may not be correct, but it will be close to, if we were to solve this algebraically, what our x value would equal. Moving on, we want to now talk about the point of inflection and what that has to do with cubics. So the point of inflection is the flat turning point of the cubic function, which is called the point of inflection, which is where the concavity of the curve changes. So when k is greater than or equal to 0, we have an increasing curve. So our point of inflection occurs here at the point 0, 0. So this is where the curve changes from concave downwards to concave upwards. So you can see that for concave up, it looks like it is the smiley face here, and it's from 0, our x value is greater than 0. And then when we talk about our concave down, it is the values, our x values that are less than 0. When k is less than 0, we have a decreasing curve. So this cubic function is decreasing, and it has a point of inflection again at 0, 0, where the curve changes. So our curve changes from concave upwards. So when x is less than 0, when our x values are less than 0, it is concave up. And when our x values are greater than 0, we have that our curve is concave down. So now for the graph of y equals k bracket x minus b plus minus b all cubed plus c, this has a point of inflection at BC. So that means whatever our b value is and our c value is where our point of inflection is going to occur. Let's look at an example. We want to sketch the graph of y equals x cubed minus 8 showing intercepts. Now for this one, we want to show intercepts, so we're not going to be too worried about where all our points are. We're just going to sketch it showing our intercepts. So you could do a table of values, but you can also find out where your x-intercepts and your y-intercept occurs. So for our x-intercept, we let our y equal 0. So that means we'll have 0 equals x cubed minus 8. Okay, and so we're going to plus our 8 to both sides of the equation to get x cubed equals 8. And then we're going to cube root both sides of our equation to get x equals the cubed root of 8, which therefore equals our x-intercept of 2. We then want to find our y-intercept. So for y-intercept, we want to let x equal 0. So that means we'll have y equals 0 cubed minus 8. So therefore our y-intercept will be equal to negative 8. So then what we need to do now is we need to find out where our point of inflection is going to occur. So our point of inflection, how we find out where this is going to occur is that we need to look at our graph. And, well, not at our graph, but at what equation we have been given. So we have been given y equals x cubed minus 8. So now this isn't in the form of y equals kx cubed. It is of the form, however, y equals k bracket x minus b cubed plus c. It just means, that's not really a straight line, it just means that we have y equals 1 bracket k cubed minus 0, all cubed, minus 8. So therefore, in this case, our b equals 0 and our c equals negative 8. So our point of inflection is therefore going to be 0, negative 8. So now let's sketch the graph with the information we have. So what we need to do is we need to work out an appropriate scale. So we're going to go down by 2. So it'll be minus 2, minus 4, minus 6, minus 8. And we're going to go across by 2s as well. So 2, 4, 6, 8. Ups. 2, 4, 6, 8. And across by 2s. Okay, so now let's sketch our function. So we know we have an x-intercept of 2, so we have a point there, and we have our y-intercept of negative 8, and we have our point of inflection occurring at negative 8. So that means our graph is going to start here, and then we go up through negative 2 all the way up. Make sure that we add arrows to our graph, and then we want to write that it is the function, so it is y equals x cubed minus 8. So we want to label our graph as well. Okay, moving on. Next, we want to sketch the graph of fx equals negative 2 bracket x cubed, x minus 3 cubed plus 2. So what we have is we need to find our x-intercept and our y-intercept. So for our x-intercept, we let our y equal 0. So we have 0 equals negative 2 bracket x minus 3 all cubed plus 2. So we're going to minus our 2 to both sides. So we'll have minus 2 equals minus 2 bracket x minus 3 all cubed. We're then going to divide both sides by negative 2. So that we'll get x minus 3 all cubed equals 1. We're then going to cube root both sides. So we'll get x minus 3 equals the cube root of 1, which just equals 1. And then we're going to plus 3 to both sides as well. So we'll get x equals 4. So therefore, our x-intercept equals 4. For our y-intercept, we're going to let x equal 0. So we have y equals -2 bracket 0 minus 3 all cubed plus 2. And when we sub that into our calculator, we get 56. So therefore our y-intercept equals 56. Finally, we need to work out what our point of inflection is. So for this one, our point of inflection, if we look up to our equation, you can see that we have our k is -2. We have our b being -3 and our c being 2. So let's identify those off to the side. So we have k equals -2, so that means it's less than 0. We have our b equaling 3, and our c equaling 2. Now the reason why b equals 3 and not -3 is because that's what the root will be, and because if we go back and have a look here, it is negative in our it is negative here, and that's what our b equals. So our b equals 3. So therefore our point of inflection will be the point 3, 2. So now what we need to do is we need to sketch the graph. Now with this one, because k is less than 0, it means our graph is going in the opposite direction. So it is first concave up until it gets to the point of inflection, and then it's concave down. So with this one, I'm not going to put a y and an x axis on this just yet. I'm going to sketch the function and then put them on. Reason being is because what we need to do is, because the scale is off, it'll be a very big picture, but we just want to sketch it quickly. So we want our 4, we want to go through the point 4, but we want to come down, and at 2 we want to have the point. I am actually, scratch that, going to put on where our 2 and our 4 will be, and I will say that our point 3 is there, and we'll say that 56 is up here. So just by putting these little bits of information on, they don't have to be to scale appropriately. They just sort of have to show that it is a bit further. 3 would probably be more down here. Okay, so now we're just going to go through and draw our function, having our point of inflection going through the point 3, 2. 3, 2. Sorry, so that means that this is actually a 3. Oops. There we go. And then we finally just need to write the function on here. So it's f x equals -2 bracket x minus 3 all cubed plus 2. Finally, we want to show that y equals 2x cubed is an odd function. So just recapping our memories, an odd function is when we sub in -x for x, we get the negative version of the function. So if we sub in -x into our function, we get 2 times -x all cubed, and negative of a cube keeps it negative. So let's take that negative out the front, so it'll be -2x cubed, which equals the negative version of the function. So therefore our function of y equals 2x cubed is an odd function. Now we're going to look at if a cubic function has 1 y-intercept and up to 3 x-intercepts is what it has. So we can sketch the graph of a more general cubic function using intercepts. So this will not give a very accurate graph like I stated up here. We didn't get a very accurate graph for example 3 when we sketched the function, but we got the general gist of what was going on from the information provided, and we also showed all of the information provided. So this will not give a very accurate graph, but it will show the shape and important features. So that's what we need to make sure that we do. So for the graph of y equals k bracket x minus a bracket x minus b bracket x minus c, it has x-intercepts at a, b, and c. For example 5, we want to sketch the following graphs, describe the shape of the graph, and state its domain and range. So we need to, for this, find our x-intercepts. So for our x-intercepts, we want to let y equal 0. So 0 equals x bracket x plus 3, x minus 2. So therefore our x-intercepts will equal 0, minus 3, and 2. For our y-intercept, we need to let x equal 0. So that means y will equal 0 times 0 plus 3 times 0 minus 2, which just equals 0. So therefore our y-intercept equals 0. So what I'm going to do is I'm going to plot where these points are on the graph. So we're going to say that that's 1, this is 2, that's where 0 is. So that's 1, that's minus 1, minus 2, minus 3. And so that our point is going through minus 3, 0, and positive 2. So we're not going to worry about what our y-intercepts are, we're just worrying about where our x-intercepts are. Oh, and because our y-intercept is 0. So we're not worrying about our y scale. What we now need to do is we need to work out whether our graph starts up here and goes in a downward motion first, or whether it starts here and goes in an upwards motion. So we don't know this unless we test the points. So we are going to test what happens to our graph when x is less than our minus 3. So we're going to let x equal negative 4. So when we let x equal negative 4, all we do is sub in negative 4 into our function. So it will be the function of negative 4 equals negative 4 bracket negative 4 plus 3 bracket negative 4 minus 2. So when we put this into our calculator, we get negative 24, which is less than 0. So when we sub one of these values in to be less than 0, that means it starts below the x-axis. So that means for this graph, we are going to be looking like this. So when our x values are less than negative 3, it's going to be below the x-axis. Like so. Now we want to know what happens between minus 3 and 0. So we're going to test between minus 3 is less than x is less than 0. So we're going to let x equal negative 1. So we're going to sub negative 1 into our function. So when we put that into a calculator, we get negative 1 bracket negative 1 plus 3 close bracket open bracket negative 1 minus 2. And we get that that it equals 6, which is greater than 0. So that means between minus 3 and 0, our graph goes above the x-axis and comes back down to hit the axis. Then we're going to test what happens between our point 0 and 2. So we're going to test 0 is less than x is less than 2. So we will let our x equal 1. So let's sub in positive 1 into our function. So 1 bracket 1 plus 3 bracket bracket 1 minus 2. When we sub that in, we get that equal to negative 4, which is less than 0. So that means our function goes below our x-axis and then hits the x-axis again at 2. And then finally, we need to test what happens when x is greater than 2. So let's let x equal 3. So we sub that into our function. So 3 bracket 3 plus 3 bracket 3 minus 2. When we sub that in, we get 18, which is greater than 0. So that means our function comes back up above our x-axis and ends above our x-axis. So now we have sketched our function f bracket x plus, so our function of f bracket x equals x bracket x plus 3 bracket x minus 2. So let's label our graph. Now we want to state the domain and the range of the graph. So the domain of the graph, it works for all x values. So it's going to be negative infinity to infinity. And our range works for all y values. So it's negative infinity to infinity. When we look at the shape, we just finally need to state what happens with the shape to describe the shape of the graph. So the graph increases to a maximum turning point, then decreases to a minimum turning point, then it increases again. So let's just quickly write that out. So the graph increases to a max turning point. Then decreases to a minimum turning point. And then it increases again. So that is how we describe our graph. So it increases to a max, then it decreases to a minimum turning point, and then it increases again. So that's where our max is there and our minimum is that point there. Looking on to example B, what we want to do is we want to do exactly the same, but for the function of x minus 3 bracket x plus 1 all squared. So what we want to do here is we want to find our x-intercepts. So for our x-intercept, we let y equals 0. So it's 0 equals bracket x minus 3 bracket x plus 1 all squared. So therefore our x-intercept equals 3 and negative 1. So then for our y-intercept, we let our x equal 0. So it is y equals bracket 0 minus 3 times 0 plus 1 all squared. So this equals a y-intercept of negative 3. So let's plot that on our graph. So we need our 1, 2, 3. We need 1, 2, 3. We'll just go across. So that's minus 1 there. And we need a y-intercept of minus 3. So what we need to do is we need to test what happens to our function. So we don't know, again, whether our function starts above we don't know if it starts up here, so if it starts above our x-axis, or if it starts below our x-axis. So let's calculate that. So let's test what happens to our function. So tests what happens to our function when x is less than minus 1. So when x is less than minus 1, we're going to let our x equal negative 2. So let's sub in negative 2 into our function. So negative 2 minus 3, and then negative 2 plus 1 all squared equals -5, which is less than 0. So that means our function will be starting below, like so. Then we want to test what happens between our x, between -1 and 3. So we test between -1 and 3. So let's let x equal 0. So when we let x equal 0, we get 0 minus 3, bracket, bracket, 0 plus 1 all squared, and we know that equals -3, which is less than 0. So this means that our our graph is going to stay below the x-axis. So far our graph is going like this. It then hits our x-axis at -1, goes through our y-intercept of -3, and then goes up to 3. And then we're going to test what happens to our function when x is greater than 3. So we let our x equal 4, sorry. So we sub in 4. So 4 minus 3 and 4 plus 1 all squared equals 25, which is greater than 0. So that means our graph goes above the x-axis like so. Don't forget your arrows. And now we need to label our graph. So it is f bracket x equals x minus 3 x plus 1 squared. Finally, our domain and range for our graph. So our domain is that it is -infinity to infinity, and our range is -infinity to infinity, and then we need to describe our function. So for our function, the graph increases to a maximum, then decreases to a minimum before increasing again, is the shape of our graph. And finally, moving on to example 6, we want to find the equation of a cubic function, y equals k x cubed plus c, if it passes through the points 0, 16 and 4, 0. Last lesson we did this but with quadratics. So when we did it with quadratics, we said whichever one has an x value of 0, we sub that one in first. So 0, 16 has an x value of 0. So we're going to sub that in first to find out what our constant is, our c value, before finding out what our equation is. So let's sub in the point 0, 16 into y equals k x cubed plus c. So we have 16 equals k times 0 cubed plus c. So therefore c equals 16, and therefore y equals k x cubed plus 16. Then we want to sub in our leftover point, so sub in 4, 0 into this new equation of y equals k x cubed plus 16. So we get 0 equals k times 4 cubed plus 16. We're then going to minus the 16 from both sides. So we get 64k equals -16. We're then going to divide both sides by 64. So we get k equals -1/4. So therefore y equals -1/4 x cubed plus 16. and that's the equation of our cubic function. Just fix up this plus. Example 7, our last example, is to find the equation of the cubic function fx equals k bracket x minus a bracket x minus b bracket x minus c if it has x-intercepts minus 1, 3 and 4 and passes through the point 1, 12. So our x-intercepts for fx equals k bracket x minus a, x minus b, x minus c is x-intercepts of minus 1, 3 and 4. So therefore, we're going to say that a equals minus 1, b equals 3, and c equals 4. So we need to substitute them into our function. So we get fx equals k bracket x plus 1 bracket bracket x minus 3 bracket bracket x minus 4. Then we want to sub in our point 1, 12 into this new function, into fx equals k bracket x plus 1, x minus 3, x minus 4. So when we sub that in, we get 12 equals k bracket 1 plus 1, bracket 1 minus 3, bracket 1 minus 4. So we get 12 equals k times our 1 plus 1 is 2, times 1 minus 3 is minus 2, times 1 minus 4 is minus 3. So that means 12 equals 12k. So we're going to divide both sides by 12. And we get our k equaling 1. So therefore, our cubic function is f of x equals our 1 bracket x plus 1, x minus 3, x minus 4. And that is the end of the theory notes. If you're following through the Maths in Focus textbook, if you're in advanced, you will now be doing exercise 3.12. And if you are following through the Extension 1 textbook, you'll do exercise 4.13.